Now it's time to jump into the first programming language in PLC systems, ladder diagram. In the previous film, I showed an example in relay logic, and that is because ladder programming comes from relay logic. I will use the same example as for the relay logic to see the similarities, and I will also show how to program this example in Codesys. And this is the example. We have a motor that is started by a relay K1. We have two start buttons. Either one of them can start the motor. The motor should continue to be started even after releasing the button. And the motor should be stopped when the stop button is pushed, and it will remain stopped even if we release the stop button, and should not be started again until one of the start buttons or both is pressed. This time we will do this in a PLC system. Here is the PLC system where we have the inputs as %IX for digital inputs and the numbering 0.0, 0.1, 0.2. And we have one output signal, percentage QX, and the first output signal is chosen, 0.0. And we have the buttons here, the two start buttons and the stop button. When the button is pushed, it will be contact, 24 volts, and we will have a high signal to the input. At the output, we have the motor relay, K1, and if the output is high, 24 volts, the relay is activated. There is one thing wrong in this picture, and that is the stop button. I have chosen to connect the stop button as a normally open contact. We should not do that. Stop buttons should be normally closed. The reason for that is now we are waiting for a high signal, 24 volts, here to stop the motor. If something happens here, for example, we lose power here, or this cable is broken, then we cannot get 24 volts to here, and the motor cannot be stopped. In this example, I've chosen to have the stop button normally open, because that will show the similarity between the ladder logic and the relay logic. But the correct way to do this is to have the stop button as normally closed, which means that until we press the stop button, this signal will be high. We have 24 volts here until we press the button, and then we will have 0 volts. So this is the correct way to do it. And if anything goes wrong here in the connection, we will have 0 volts in here, and that will automatically stop the motor. But for this example, I will start using this configuration. What we will do then is that we will program the PLC to do exactly this. For now, we only have the signals, and we will make the program. I will make the program in ladder diagram, and I said that it's really similar to relay logic. And we are using the same kind of symbols. Here is the relay, and here we have the normally open contact and the normally closed contact. In ladder logic, we have a coil, we have a normally open contact and a normally closed contact. I will show this in Codesys. I have opened a new Codesys program. Of course, ladder diagram programming can be done in any PLC programming environment, but I will use Codesys for all my examples. When I started up my example, I forgot to change the programming language, but no problem. I can make a new POU. I click my right mouse button on Application, go to Add Object, POU. Here I get a new menu where I can choose if I want to make a program or a function block. I will make a program. I can choose the programming language, and then I choose LD, ladder logic diagram. And then I should create a better name than POU, ladder latch. And I can hit enter or add. Here I have my local variable list, the header, and here I have the area for the program. Now we can see that I have a vertical line here. That vertical line is similar to the 24 volts connection in the relay logic. So what we will do here now is that I will build my program using coils and contacts, normally open contacts and normally closed contacts, just as in the relay logic. I will start with my coil. Now, when I'm programming in ladder, I still have those function blocks here in the toolbox. But hidden down here, I have the ladder elements. I have the contact, negated contact, I can make parallel contacts, coils, and so on. So I will start with the coil. It's here, I can drag it, and I can put it either there or there. But here we have add output. I will add it here. The coil will be my output from the program. Here it is. This will be my motor, the signal that goes to the motor relay in the output. I don't have any output modules here in my device tree because I'm using the simulation version still, but I can prepare it as an output by adding it to the global variable list, which means that I need to have a global variable list. Right mouse button, click, application, add object, global variable list. And here I can add my variable motor as a boolean. I'll put my list here. We can also see by dragging here that this is a global variable. And now I can connect this to the variable motor. I have the 3 dots over here, but I can also just write the name motor. But Codesys did not recognize motor. It's asking me if I want to declare a new variable motor. No, I have it here, console. There is something wrong. And that is the line of code in the beginning of the global variable list. If I go to text view, I can remove this line, and now motor is recognized. The other way is to write GVL as the name of my global variable list, dot motor, and then Codesys would have found the variable. Okay, when will we start the motor? We will start the motor from a start button. If I click the connection line here, I get a menu up here, and here Codesys shows me what I can choose from. I want a contact. This is my start button. Start 1 is not declared. I want to do that. It should be connected to a physical input. It should be in the global variable list. Okay. And I see that start 1 is now in my global variable list as a boolean. I want to have the stop signal as well. I can put it either here or here, as long as the motor signal is affected from the stop button. Now, I connected my stop button like this, in the wrong way, which means that when I have a high signal to my input here, the motor should be stopped. That means that the signal from my stop button should cut the current to the motor, or the signal to the motor in this case, which means that I want to have a normally closed contact, or a negated contact, like this one here. This is stop. Stop is an input variable. It should be global here, and it is in the global variable list. I also wanted to have my second start button, start 1. I can declare it right away in order to get it in some kind of a logical order in my list here. Copy this line, it's in here. Now Codesys immediately tells me, okay, you already have one signal called start 1. Okay, this one should be start 2. I should start the motor either if start 1 is true or if start 2 is true. In relay logic, that was a parallel connection. It's the same in ladder logic. We'll click this one and I can add a parallel branch here, and I will have my start 2. We can already see the similarities with the relay logic. We have the connection here for the signal. If it's cut here by pressing stop, no signal to the motor, but as long as stop is not activated, the signal goes through here, and then it can go either here or here if start 1 is activated or if start 2 is activated. This is an OR in ladder logic. Then we have that latch function. We made a latch in relay logic by using the monitoring contact from the motor relay in parallel to the start buttons. I can do the same here. Click here and add a new parallel branch here. I used the monitoring contacts in relay logic. If I want to use them, I have to connect them to the PLC. I don't really have to do that because I have the signal motor. I have motor here, but I can reuse it here, motor, which means that if motor is true here, motor is automatically true here, it's the same signal, which means that the signal can go through here to here until the signal is cut when stop is activated. We can try this out and go to online simulation to have the simulation on, and then I can log into the simulation. No simulation exists. Okay, create it. Yes. And we can start it. Now we see that the program that we wanted to run is gray. And if I click on the signal, nothing happens. That is because this is not the program that is running. It's my program PLC PRG, because that is the program that's in my main task. I have to correct that. Log out. This program I don't want to run. I can remove it from here. Just click delete. And I drag and drop the correct program to here. Try it again. Log in. Now I'm asked log in with online change or download. It's a completely different program that I'm logging in with. Download. Okay. Now things are a bit better. This program is up and running. Just have to start it. Now I don't really see the prepared value column here. So I can drag in the columns. There it is. Okay, let's see if I can start the motor. I can double click on the contact here, and then I can see the prepared value. I can also see the prepared value here. Now start run is true, and I go to debug, write values. The value is written, and the signal is coming through. Now the motor should continue to run if start run is false again. I click in prepared value, Control F7 to write the values. And the motor continues to run because the signal can go this way. Let's see if we can stop it. Pressing stop, prepared value, true, Control F7, yes, the motor is stopped. And it will remain stopped if I release the stop button if stop is false. The motor remains stopped. The final thing to test is to see if this is stop dominant or start dominant. If I try to stop and start at the same time, prepared value true, stop and start run. Control F7, the motor is stopped because the signal is cut already here. Remember that the connection that I have been using is with the wrong type of stop button. What should I do if I had the correct type of stop button, the normally closed one? Then we have a normally closed contact here, which means that this signal will be high until I press stop. Then it will be low. Go back to codices. So if the stop button is not pressed, the signal stop should continue to be true. And as long as the stop button is not pressed, we should be able to start the motor. We changed from a normally open contact to normally closed contact in the input configuration, which means that we need to change from a normally closed contact to normally open contact here. I can do that by using the right mouse button on the contact. I don't want to insert a contact because then I will add another contact. I will use this negation. I already have a negation. Using the negation again will remove it. We'll try this out. Log in. And I can log in with online change. It was just a minor change. Now stop is true, which means that the stop button is not pressed. Start is also true, which means that the motor is running. I can release the start button, prepared value false, Control F7, and the motor will continue to run until stop here is false, which means that in the correct configuration, the stop button is pressed. We can do this in another way as well. I log out to show you. If we see in the menu up here, I have a coil, but I also a set coil and reset coil. A set and reset coil together will be a latch. So I can use a set coil here. I right click and here I have set reset. I click on that, I will get an S in this one, set. If I just have a set without a reset, the motor will continue to run regardless of what I do. So I always have to have a reset when I have a set. I will add a network. I can take it over here, I can drag it and release it either below or above. Below. You can see that this signal line, it's continuing. And here I want to have a reset coil. Have it here, ladder elements, reset coil. This will set the signal motor, and this will reset the signal motor. This logic doesn't really make any sense now because this was the latch. We can't really have the latch both here and here. So this should be removed. We should not have stop for the start function. So it should be removed from here. Now I only have the logic for starting the motor. When should the motor be stopped? It should be stopped when we press stop. And remember now that I reconfigured, stop is true when the motor should be running, and it's false when the motor should be stopped, which means that I should add a negated contact here. Let's try it out. Log in. I will log in with online change because that's faster. We can see that motor is true because it was true when we left the program the last time. We'll try to stop it by using the false signal stop here. Prepared value, false, Control F7. Now we can see that this line is true and motor is false. The motor is stopped. We try to start it with user start 2. Prepared value true, Control F7. The motor is stopped. Now I have a true signal to both set and reset. And as in all PLC programming, when I write the same signal twice, we will use the last value. The motor is set and motor is reset, which means motor is reset. But when I release the stop button, it will be true, Control F7, then the motor is started. Now to the list of symbols for ladder diagram, we can add the set coil and the reset coil as well. Now I have built 2 stop dominant latches in ladder. Just as in the relay logic, I can make start dominant latches as well. In the last configuration I have here, it's quite easy. I can just mark my network, drag it, and drop it above. Now it's start dominant because I will be writing to motor twice, but if both those are true, the set will be the last one I will write to. This will be start dominant. We'll log in and try it. Now the motor is already started because that's where we left it, and start 2 is true. If I want to press the stop button as well, it should be false. Okay, I press the stop button and start 2. The motor is running. This is true, but this will overwrite the reset. So this is set dominant, start dominant latch. And here is the program with only one coil without set or reset. I have the latch function here where I reuse motor and I will stop. Just as in the relay logic, this will be start dominant. If I start and stop at the same time, the signal can go through here. It was the last configuration we tried. Start 2 is true and stop is pressed, hence stop is false, motor is running. If I release start 2 now motor is stopped because the signal cannot go through here anymore. If I release the stop button, the motor will remain stopped. But now I can start it by pressing start 1 and it started. I can release the button again. Now the button is released, start 1 is false, and the motor continues to run because the signal goes through here. Now I have shown you the similarities between ladder logic and relay logic. We can do a lot more in ladder logic than we could have done in relay logic, but that would be using function blocks, and we will continue with function blocks in the next films.